Okay, so if I give you a triangle that's like this, and then I have, and it's a prism, then what happens all right, so let's say that this is 5. That's the right angle. And this is 7. And 49 and 25 is 4. 74. This is the square root of 74. How did I get that? If I did it right. This is your right triangle. So the Pythagorean theorem says a squared plus b squared equals c squared. And I think 49 and 25 is 74, if I did that right. But why did I put square root?
Because it's c squared.
Because I don't want c squared, I want c. So I have to take square root of c squared to get c. Okay, now, so those are the 3 sides. Okay? Let's say that this length is 11. Then I have 3 rectangles. I have 3 rectangles. I have an 11 by 5, I have an 11 by 7, and I have 11 by square root of 23. So how do I find the area of this one that's closest to us? I'm going to multiply 11 by 5, get 55. Then the one that's on the bottom will be 11 by 7, which is 77. And then the other face over here is 11 times square root of 64, is what it is. But then I have to do the 2 ends. So the value of the area is 1/2 base times height. And the reason that they're going to use a right triangle is because 5 is the height and 7 is the base. If I didn't use a right triangle, and the triangle came down like this, I'd still have to give you the height, but then this would be 8. Because instead of stopping here, it goes all the way to there. So now I could do something like this. 5 is on the outside, and 4 is the height. So now you have to use 8 times 4 times 1/2 for the area of this end, of this triangle, and then 8 times 4 times 1/2 for the area of that triangle, and then we have 11 times 5 for the one face, 11 times 8, and 11 times the square root of 74. That would give me the surface area of all of those faces. Okay? 3 rectangles to connect, and 2. So I'll have 5 different measurements to add together. Okay? All right, so that's what makes surface area hard. Now, if we had a pyramid, the area of the faces, we need the slant height. All right, so now I have something like this, and I'm going to so now, from here to here, with a right angle in the center, that's the what?
Altitude.
That's the altitude. That's how high this point is away from here. And then I have another line that goes like this, which is perpendicular to here. Okay? This is called the slant height. And why is it needed? Because if you're doing surface area, what is the surface area of this triangle that's facing us? It's 1/2 base times the height. Right? Now, if I gave you this side here was, let's say it was 20. And this side right here was 32. Okay? How do you find the slant height? This is what I was discussing before I remembered I need to turn the tape on. Okay, remember I said that this is an isosceles triangle? So, because this is also 32 here? Now, so therefore, the altitude of the face is the perpendicular bisector. That means, what is this distance here? It's 10, and this distance here is 10. You see the right triangle? A squared plus B squared equals C squared. A squared plus B squared equals C squared. So now I can find the slant height because I know that that's a perpendicular bisector because it's an isosceles triangle. All right, now, go ahead.
When you do the pyramid, when do you do like the 1/3 times?
All right, yeah, for the volume. But in that case, I want this number, right? I need the altitude to the point. But to do the surface area, I don't use that number. I've got to get the slant height. And sometimes they don't give you the slant height. They give you these other two numbers so that you have to use the Pythagorean theorem to find the slant height. And then how many triangles will I have of whatever those degrees are?
8.
No, look at it. How many bases on the bottom? 1, 2, 3, 4. So I'll have 4 triangles. See, there's a base here. There's 1. There's another one here. That's 2. There's 1 in the back. 3. 1 in the back. 4. Because what's that base? That base is a square, so that's 4 sides. And the 4 sides of the base become the bases of each of the triangles. And this is, I think, called, that pyramid is like a tetrahedron, so all of those surfaces, all those numbers are the same length in the bottom. Okay, now, so that is the most complex thing to do, is that unless they're really, I'm going to use this term, unless they're dumbing it down, and they give you all the measurements you need, and then it's just a matter of putting the measurements together. That's one level of doing surface area. Is that if I gave you all the measurements that you need, you still can get tricked up because we have 4 triangles, all the same size, and we have a base. And a lot of people forget to do the square of the base and add that area to the surface area. All right, so there's still ways to make up. So the first time that you see a problem, they give you the dimensions so that they find out whether or not you remember how to get all of the surfaces together. Because a lot of times we forget the base, sometimes we forget the base and the top. But after you get that, then you get into some places where the dimensions are missing and you have to use other algebra to get it. And one of the algebra dimensions in an isosceles triangle is that this altitude is a perpendicular bisector, so I can use the Pythagorean theorem with half of this, 10, with the length of this side, right? And then that will give me this length. So this times x squared equals 32 squared, and then use my algebra to find the answer. Okay, now why do you think I'm telling you that? Because at the end of class, when you have your quiz, that's going to be important. Okay? Yes?
So, in that instance, it would be 32 squared plus 10 squared, and that would equal the...
No, the hypotenuse is 32. So 32 squared equals 10 squared plus x squared.
So that's the long side.
So it has to be half of 20.
Right. That 10, because this side is 20, and that's the perpendicular bisector. So in order to be able to get this slant height, I've got to use a small triangle. Once I get the slant height, now I'm 1/2 base 20 times whatever that slant height was. All right, now, that's for one of them. How many do I have? I have 4 of them. Plus, I have to add a 20 times 20 square on the bottom. All right, now, that's complicated, isn't it? Now, and it's meant to be, because this is like a senior math class. All right, so it's meant to be complicated. All right, it has a lot of steps in it, which gives you an opportunity to mess up by either mixing up a step or not finishing all of it. All right, does it make sense? All right, other questions? Good, both good questions there. Both good questions. All right, okay, now, what we're going to do, which will also help on your quiz, is that we're going to go through the chapter 6 review, but I've got to bring it up first here. Oh, it is really hard for me right now to have to pick up my stuff and move, because normally in the 5 minutes of the class change, I'm setting up for the next class. And so I have to come in here with it. Okay, chapter 2. Where is chapter 6? There it is. And I want text. Wake up. Oh, praise God, look at that. All right, self-test. Let's look at this first problem. Can you read that? Let me try to make it larger. All right, okay. By direct measurement, okay, we don't have that. All right, use a centimeter rule to estimate the area. Compare your answer with those around you. Okay, so what do we have to do to find the area of A? First of all, what's the area of the triangle? 1/2 base times height. Okay, so we're going to have to measure this. All right, let's say that this is 4 centimeters. All right, how do we get the height? All right, Casey, this is important because you weren't here for this one. How do we get the height? Where does the height have to go? Let me ask you that.
It has to be on the left side.
It has to go up to here. It has to go up to A. So we're saying that B to C is 4 centimeters. All right, what's the height of that? The height of that, you have to bring this out and then measure. There's the height. Okay, so for an obtuse scalene triangle, the height is outside of the triangle. For a scalene triangle, the height is inside. Or if I flip this around, if I measured from A to C, I could get an altitude here. And that would probably be easier to visualize, but the way that they gave it, the altitude would be out there. And again, they're trying to get that. Now, all right, so we have this. What do you do with this one? All right, do we have the area for a quadrilateral? Is there a formula for the area of the quadrilateral? The answer is no, there's not. So what am I going to have to do? We do have one for a triangle. Can I make this into a triangle?
2 triangles.
2.
Yeah, I can make it into 2 triangles. So I'm going to draw this line here, and let's say that that is 7 centimeters. Now, what do I need?
The height of both.
I need the height. So I'm gonna get the perpendicular that comes here. All right, let's say it's 5. And then I'm going to get the perpendicular that comes here. And let's say it's 16.5. Now, how do I now find the area?
7 centimeters times 5 times
7 times this times 1/2, right? Plus 7 times this times 1/2. And that sum will be the area of the whole thing. All right, now find the area of each polygon. All right, what's the area of A? Don't call it out, calculate it, get your calculators out. Calculate the area of A. And then write it down. You got a calculator? You still packed? Okay.
3 more weeks.
Hmm?
2, 3 more Tuesdays.
2, 3 more days, okay. Ready? I trust him. He's a good catch. Okay.
He's a good catch.
Okay. Agree or disagree? All right, agree or disagree?
Oh wait, did you? No.
No, because that's not a triangle.
But what'd I do?
I don't know what you did.
Huh?
Wait,
I took
why did you have
one half base times height.
But it's not a triangle.
Oh, then what am I supposed to use?
Base times height.
Oh, okay, all right, just checking.
So we were
All
right.
right,
Agree.
okay. So therefore, it's supposed to be 15
Times 8.
times 8. Okay, 120.
Sure.
Okay, all right, now do B.
B?
Do B.
B.
Wait, let's just. That's. No.
Seven.
My calculator's autistic. I'm sorry. Yeah. Got
Okay.
it.
All right, now I'm going to do another problem. All right, let's say that this line goes all the way through here. What's the area of that gray triangle?
Same.
Huh?
It's the same.
Yep, exactly the same. Why?
Because
Because it's still 1/2 base times height.
Yep.
Okay? And that's a test question for some high-level math. Listen, that for some high-level math entrance exams, that's a test question. They'll give you the area of this, and then they'll either make a drawing like this, or make a drawing that has the same dimensions here and here. All right, and then you're supposed to say, if this was 7.5, then that was also 7.5, and move on, as opposed to trying to calculate. You see how that works? So a student that had learned the skill that we just talked about, and that Caitlin knew, right? Then they would be saving 25, maybe a minute, 25 seconds to a minute, because they got the answer like that, because they had a skill that they could have learned, where the other people that forgot it would have to turn around and recalculate. All right, and that's some of the ways that they change problems so that those that are excellent in math, they can move quickly through and get more answers. Okay, all right, so next one I'm not even going to do. All right, trapezoid I do want you to do. All right, I want the area of the trapezoid.
Would that still just be based on height?
It's a triangle with the top cut off. So you're going to use the triangle formula,
Oh, okay.
right? Only instead of the triangle, how tall is the top of the triangle? How wide is this point up here?
7 something.
No, this point up here is 0 wide, right? So here, instead of taking 3 plus 0, we're taking 13 plus 7, which is how much?
42.
No, 13 plus 7 is not. 20, half of that,
It's 10.
and 10 times 6.
It's 16.
Yeah.
Wait, what?
Let's go. My mental math going on.
Right.
Wait.
All right, you add the two bases together and get 20. 1/2 bases times height is 10 times 6 or 60.
Or I did that.
Okay, all right, so wait, what we've got?
I was thinking cut off the triangle on the left
All
side.
right, no, because we don't know what the measurement will be here. We don't know how much this is. There's your base. You can't do it that way. All right, so the only way that you can do it is this distance is 0 and this distance is 3. When I add those together, I get 1/2 3 times 5. This distance is not 0, it's 7, and this distance is 13, so it's 1/2 20 times 6, which is 60. That's another way of looking at a trapezoid. Right? These two are parallel, and so it becomes a triangle with part of it cut off. And so we're going to take these two bases and add them together, and then take 1/2 base times height. All right, let's see if I can do this. Okay, now we got a fun one. Okay, so this is, all right, they gave us the dimensions. It says how many cubic feet of water is in that trough? Okay, so if it's asking for cubic feet of water, what is it asking for? Surface area or volume?
Volume.
Volume, okay. So how do we find volume? All right, because this is a pyramid turned upside down, we have two ways to do it. One is that we take the area of this triangle and we stack 5 feet higher. All right, so can we get the area of that triangle? All right, now look at, you see the right angle in it?
Yeah.
So therefore, if I turn it on its side, I have a base of 2 and a height of 2. So what's the area of the triangle? 1/2 base times height. So this area is 2 square feet. That triangle. Agree? Everybody see it? All right. Any question on how I got that? Right. Because this is a right angle, the height of the triangle is the same as the side of that right triangle. Because the altitude is the side. So therefore I have base times height times 1/2, which is 2. So this is 2. And, whoops, it's supposed to be 2, not 3. And how high have I stacked it? I've stacked it 5 high. So then what's the area? Is 10 feet cubed. There's 10 cubic feet in that trough.
That's a funky looking trough.
Okay. Now, Caitlin, you're the only one that hasn't got a project reserved, seeing as how that says projects.
Whose project this is?
Yeah, which ones are taken so far?
Hmm?
Which ones are taken so far?
There's a lot of
I can tell you,
projects.
okay. Let's see, I think these are projects here.
But it's doing 12.
Hmm?
Moved.
He's doing 12, I'm doing
Yeah.
11.
Moved 20.
Yeah.
Oh, 12, okay.
Don't put 12.
All right, let me get down here.
19.
All right, algebra review, okay. All right, now, just look at the square root part, because if you have your Pythagorean theorem, this becomes important. All right, if you take those two square roots and multiply them together, it's like taking the square root of the product of the numbers underneath. So what is 8 times 2?
16.
And the square root of 16
4.
is 4. So the square root of 8 times the square root of 2 is the same as the square root of 16, which is 4. Okay, now what happens on the next one? What's the square root of 27? All right, it has a 9 in it, right? So I can separate the 27 into square root of 9 times square root of 3. Right? Now, if I have a square root of 3 on the top and a square root of 3 on the bottom, won't they cancel and make 1? So what's left? Square root of 9. How much is square root of 9?
1. 3.
3. Square root of 9 is 3. Okay? So, the law is that the product of two square roots is the product, or is the square root of the product. The quotient of two square roots is the square root of the quotient. So you can take the two that have the same root, doesn't work if they're different roots. You can take the two that have the same root. Now, what that doesn't say, that I think you all also know, what exponent represents square root?
1/2.
1/2 is correct. So if, pick your calculators up. Pick your calculators up. Put 237 in your calculator. All right, now, if I ask you for the square root of that, raise it to the 0.5 power. And you're done.
Ugly number.
It's an ugly number because it doesn't come out even. All right, but the reason I said that is suppose that you have a squared plus b squared. Right? And a squared plus b squared equals 237 when you're done. Right? Normally, what you would do is that you would have to go second square root and then recopy 237. But if you understand that square root is the half root, as soon as you get the sum of a squared plus b squared, raise it to the 0.5 power, and the answer is there in a short amount of time. Okay? All right, so let's look at this. Now, this is adding, isn't it? This is adding. All right, this is a little bit different. If you, is there a perfect square in 8? Isn't it square root of 4 times square root of 2? So square root of 4 is 2, and I'll have a square root under as well. And 50 is 25 times 2. What's the square root of 25? 5. So I have 2 square root of 2 plus 5 square root of 2. It's the same as 2x plus 5x. So it's 7, but not 7x, it's 7 square root of 2. All right, so if you ever have a place where you have to add these, if the number left over is not exactly the same in both, you can't combine them. Because can you say, what's the combination of 3x plus 2y? The simplified form is 3x plus 2y, because you can't combine them, right? So the only way to combine those is they both have a square root left over that's exactly the same. All right, Caitlin, you got that? What are you looking at? Oh, okay, all right. Manicure, listen, manicure is starts at 12:30 over in the other building. Okay. You know what's funny about that is that when I was doing the alternative high school, they had a what do they call? What's that industry called? Where you do nails and hair, cosmetics.
Yeah.
They had a cosmetics program in our building, all right, and they also had a medical secretary assistant program in our building.
Wait, where you taught?
Yeah, it was the alternative high school in Hall County. All right, and then they built another building, and they had a restaurant industry. It's called the Linear Career Academy.
Yeah, I know what it is.
Yeah, and so I taught there for 5 years. Okay, all right, so let's look at this problem, because this is one you need to know how to do. All right, A, you see A here? All right, it is a difference It's
Of
2
squares.
conjugates, so it's going to make a difference of squares. So what is 1 squared? Come on. 1 minus, what is the square root of 2 squared?
2.
It's 2. What's 1 minus 2?
2.
Negative. 1 minus 2 is negative.
It's negative 1. Negative. Okay. Now, okay, look at this one. When you take square root of 6 and square root of 8, do you notice they both have a 2 in them, right? That's going to make the square root of 2 squared, which will be a regular 2. What's left in this if I take a 2 out? 3. What's left here if I take a 2 out? 4. Oh my, square root of 4 works, right? So that is going to be 2 times 4 times square root of 3, or 8 square root of 3 for this part. All right, and so this splitting of square roots is how you simplify. Now, guess, if you can, guess where I first started teaching those A through D problems. What grade level?
3rd grade.
Huh? No, not pre-K.
3rd grade.
8th grade.
3rd grade. 3rd grade.
Yeah, 8th grade. 8th grade. In Georgia, this used to be part of the 8th grade curriculum. So when they got into high school and they finally learned Pythagorean theorem, they could already manipulate the numbers because they had it in 8th grade. I don't think they even teach that anymore in 8th grade. You know, and so what's happened is you've come up through a system to where you know how to square something, but it's really hard to manipulate because you haven't had any practice in it. Right, that's the reason that that's there. Okay? Now, all right, what would you do with this problem if you needed a decimal? 1 divided by square root of 2. What would you do if you needed a decimal for that? What would you get?
1 square root of 2.
You put it in the calculator, don't you? So put in 1 divided by, and then square root of 2.
0.7071067.
Boy, how'd that solve that issue, right? Okay. Now, the way that you had to do that before is that you would have to take this problem right here, and you pull your division house, and you go 1. And you say, 1, that can't go into that, so that's 0. And that goes into that 7 times. All right, I have 4 of them, so 7 times this is 28. All right, and that makes that 9, and that makes 8, and that makes 9. And then I subtract. And then I have another 0, and say how many times does 14 go into 10? It goes in no times, right? So I add another 0, and then that's how we used to have to do that because of not having calculators in the 8th grade. But now that we're here, you just have to learn how to put it in the calculator. Okay. All right, now I want to see if I can get back. Let's see. Okay, did we start here? No, these are, it just looks different. Okay, all right, so now let's look at this. Problem number 2A. All right, first of all, do you have to even think about 2A?
No.
All right, okay, what about 2B? What's the difference between 2A and 2B?
One's based on height, one's 1/2 based on
1/2 base times height for B. Okay, what about C?
Still 1/2 based on height.
All right, to find the perimeter for C, what's the perimeter of C?
Perimeter?
Perimeter.
9 plus 9 plus.
All right, so how many 9s are you going to add together?
7 times 9.
So what will the perimeter be?
36.
36 is the perimeter.
Yeah.
period, because it's just the distance around, right? Okay, now what's the area?
7 times 9.
7 times 9, right? Okay, now, same thing with D, right? That's just what? How do you get the area of D?
1/2 base.
1/2 base times height. If you know that, you know it. If you don't, now what about E? It's still 1/2 base times height, but what two numbers are you going to multiply together? You're going to have square root of 8 times square root of 2 times 1/2. All right, square root of 8 times square root of 2 is, we just looked at that, is a square root of 16. So how much is that? 4, and then when you take half of 4, you get dose. All right, now, all right, what happens for the area of F? Look at it.
We did that last week.
Huh?
We did that last week.
All right, okay, what do you do? What do you have to do to find the area? You have to multiply the what? I'm looking for L. Huh? Can you? Number F. What do you have? What numbers do you multiply on F? You have to multiply base times height, right? What's the base of that? X. What's the height?
5x.
All right, so when you multiply those together, what happens?
You get a number.
What number will you get? Because you're right, you look at a number. Won't the x's cancel?
Yes.
So what's left?
5.
Okay. What happens if the base of that rectangle was x squared? If the base of the rectangle was x squared, what does the area become?
20. 10.
Huh?
10.
It won't be 10.
X
Almost. All right.
Well, there'd be an X left, and there's gonna be 5.
Yeah. All right. So we have this. We have x squared times 5 over x. So one of the x's will cancel with the x squared, and so if that were it, if this were a square, then 5x would become the area. Now that's strictly algebra, but you know that's the way you have to do that. So for this problem, the answer is 5. All right, now what happens when you get to G?
X plus.
You have to multiply those together. That's FOILing, and now we're back to the quadratic equation, and you're going to have to either factor or you're going to have to use the quadratic formula to find the value of x. All right? What about here? It's 1/2 this times this. Wow, I don't even want to do that. Let's skip there. Because, all right, how do you multiply these? All right, first you multiply all of this by x squared. So that's going to become x fourth plus x third plus x squared. And then you're going to multiply them all by minus x and line them up. And then you're going to multiply them all by 1 and then combine them. So it's going to be ugly. And then you have to take 1/2 of everything. So it's even going to get more ugly. All right, now this one we looked at. And I think we did this. We have a right triangle. We have a right triangle here. What's the area of that right triangle? 1/2 base times height. What's the area of this triangle? 1/2 base times height. I'm not sure what that is yet. Okay, what's the area of this triangle? All right, see the big triangle now? It's 1/2 base times height. That's where you get into it. And then this one, so therefore I have 1/2 7 times 5. I have 1/2 10 times 8. And I have 1/2 9 times 2. And that's the area of the whole thing. Okay? And the problem that, and when we did this the other day, the problem that I have is when I do this, that 7 is not for this part, that 7 is for the whole part. This 10 is not for this part, the 10 is for the whole thing. So, but when you put those in, okay. Now, same thing would be true here. If I take this right here, now I have a triangle that has a height of 8 and a base of 10, so that's going to be 5 times 8, 40, right? And then if I do the same thing here, I have a height of 10 and a base of 12, a height of 6 and a base of 16, and a height of 6 and a base of 15. And now you are being able to use that by adding the lines, but that is because they gave you these altitudes from this point in the center. And the name of that point is a centroid. That point where they all come together, it's called a centroid. Okay. All right, now, okay. All right, so this drawing, I'm going to go over this real quickly. If AP and PB are equal to each other, then those two triangles are equal. True. Because they each have the same height, and if AP to PB is equal. If AP and PB are not equal, then the triangles are different areas. All right, this is the one I tried to get you to draw. Okay. If in a kite, the diagonals meet at right angles. So we have a base from A to B, and if we have the height, we can calculate the area to one side and the area to the other side if we have the height. And there's actually an algebra method where D to the middle, dm to MC, that distance you can actually use that whole number and then use the distributive property times the base on the other side, the AB. Okay, yeah. See, they give you AB is 6 and DC is 10. All right, so this has been split into 3 and 3, right? And so I'm going to have 1/2 3 times this plus 1/2 3 times this, which means I'm going to have a total of 10 times 1/2 times 3 using the distributive property, and that allows you to multiply those two together and take half. All right. We've done that one. The reason that I'm going through these pretty quickly is, okay, let's see, did we do this one? Prove that the equilateral triangle D to C to E to F, prove that quadrilateral equals the area, the area of the triangle. Okay. I don't remember that one. A, F to B. Okay. All right. The reason I'm doing that is that we have 10 minutes of class left, and you have a 10-minute quiz.